Wonderful. Well, I think I recognize everyone else. Thanks for being here. We'll talk more. I better get started here, though. There's a reminder, but we just went over that, so you're probably okay. Now, I do apologize. This PowerPoint is wordy, but it's an extraction from the 2021 request for proposals. And so, yeah. The scope of work for this session is prototype design development. And so you have a design and you want to refine it. And so it's an opportunity to complete the design details, the design analysis. Maybe you've done some testing of a beta prototype unit or component, and you're trying to reach readiness level for testing of a prototype that's much closer to the production design. Okay. So it needs to be either a wind turbine or a component for this project. Okay. And in this turbine design concept or component should have already gone through, at a minimum, the preliminary design stage of development. So our idea is too early. You've got to get it to a spot where it looks pretty close to something that can be refined into a prototype, if that makes sense. Now, I know this is a gray area, but I think we'll come away with a better understanding of maybe what's too early or even what's more advanced than this stage. Now, the component, a blade, an inverter, a tower, must be associated with at least one wind generator and have stated support of that OEM. I've not been around working in CIP very long, but in the past, I believe, there's been some experience of an interesting component developed and then zero utilization of that component by an OEM. So we want to see that tie. Like if you're going to make a tower or a blade, who's going to use it? Because if a blade or a tower in a vacuum serves the industry very little. NREL will provide technical and testing guidance, including a technical design evaluation and what design and testing challenges and capabilities need to be addressed for success. All right, so this is great. You've got a pretty good idea, and it's gone through preliminary design, and now you're going to team up with with NREL to try to identify a path forward, and with the cost share, the benefit. As part of the technical design evaluation, NREL will complete a detailed concept viability, which must be successful to secure full requested funding amount. So that's speaking to the go no go decision. The project result is expected to be, now there is the word final, and but I think that's not as, that's hard to say the word final, right? It's like the word always and never. But anyway, the project is expected to be a final prototype turbine or component design, which would allow the construction or testing of that prototype. Next step would logically be prototype manufacture and installation. So at the end of this, you don't necessarily have anything physical, but you have a design ready to be built. The task table was provided. This task table was provided in last year's RFP for this topic area, and you see all this in the scope of work. You've got tasks in the section 4. You've got deliverables in section 6 of the statement of work. Task 4.1 is develop a summary of the work effort. You send that in, and as we saw yesterday, that is used for the creation of a project summary that we intend to make a public-facing document to show what we're all up to. Task 4.2 is a collection of technical and economic information on the turbine design and a design evaluation presentation to NREL staff and possibly other DOE lab personnel if it's a particular if there are experts at those labs that can help out. Technical design evaluation is over here in the right-hand column, laboratory assistance, and we've just talked about that feedback and go, no go decision, which we will make based on that design evaluation. 4.3, identification of additional work needed to complete the turbine design efforts. So this is in your column, is you create a report of things we need to work on as identified in the design evaluation. And NREL will provide a feedback on the gaps analysis capabilities required and types of entities qualified to provide the support you need to move forward. And this is this is applied to all these remaining tasks. We give you feedback, you identify what needs to work on, issues to work on. And then in 4.4 is a report on the implementation of additional research and analysis tasks. So maybe you need to look into a different blade material. And then here, and you've identified that here. Here you've written a report on the implementation of the research into that new blade material. And then 4.5, you send in a final design, possibly a report on a beta unit construction and a plan for testing. And then your 4.6 task is the production of detailed final design documentation and drawings, which may include additional testing and design efforts. So you're working on the design incrementally throughout this 2-year process, and the final report includes a report on what we'll see later. So we talked a bit about the concept design evaluation yesterday, so you probably have a pretty good idea of what we're looking for here and that it's a go, no go decision. It's a warm up for certification. Now you may feel pretty far from certification, but this is a modern era where you've got to get there. Now, technically, there's a period of time where, look, you need to put this turbine out there to some customers, and it may not be certified yet, but your end goal for a mature product to be sold widely is going to be a certified design. So it's never too early to buy, read, and design to those standards to which you will be certified. And this design review is sort of a first go at articulating your design and a report and discussing it with technical experts, much like you'll have to do in a much more structured environment as part of certification. We're looking at, is this design likely to be successful? And successful means what? Any ideas out there in our group of experts? You guys, what is success? What are we looking for in terms of, will this be successful? Any ideas on that, Tim? Anyone else? Joe? What does success look like? It's okay, you don't have to answer.
No safety issues.
Yeah, you don't want this design to create an unsafe condition. That's a big no-no in the distributed wind industry, right? Avoid unsafe conditions. That's right. Erica says LCOE has market viability. Yeah, it could be a design that will kind of work, but is all that worth it? That it's all the money spent on it divided by all the energy out of it has to make sense. That's right. LCOE is a good factor.
Brent, are you talking about your line there? Likely to be successful. That's what you're saying, right?
Yeah. So, gosh, how do we?
What is likely to...
Yeah. What does that mean? At this stage, how do we decide if this is likely to be successful? And we're hitting on some good points here. And it's like, well,
yeah, I mean, likely to be successful. You're going to review it against the standards, right? You're going to check and make sure there's a design basis that lines up with standard requirements and material information and drawings, things like that.
That's
You're
right.
gonna look to verify that a product exists and a method exists for design.
Mm-hmm.
In my opinion.
No, those are good points. Can it be certified? Does it make economic sense? Will it be safe? Is this something that will be competitive in the market? It's not like, can you make something that spins? Right? That's not it. Can you make something
that is a success? That is a success, yeah. But
it's too low. Can you make something that converts wind into some electricity? That's still too low. We have to think about, what is success going to look like for this design? So it's, it's subjective, but we're trying to use good quality engineering to make this assessment while we're working on this technology development as a team. Review what testing you've done so far, what analysis you've done so far, what performance you think you'll see, how did you get there, what assumptions are you making, and of course there's some uncertainty there, but you've got to be able to articulate all these things and make it substantiated. So inevitably in a room of experts with a conversation about the very dirty, defined details of your design, you'll come away with some areas of concern, some areas that are on the wrong path, some technical details to remedy, and then you'll write those up in a report and make a path toward resolving those, and then keep going. If it's a go decision, you're going to implement those improvements. You're going to overcome those problems. And there could be supply chain. Is it manufacturable? Is it certifiable? Is it cost effective? Is it safe? Previous awards to unconventional designs, which do land here in this topic area, are not just ideas. Some designs look good on paper. Some designs have a patent. Some designs look really cool with CFD lines flowing through them. But have you done some significant testing or analysis to really evaluate this design? Okay. The deliverables associated with this are aligned with the tasks. Okay, so each task is you're doing something, and then it results in a deliverable, which you send in and get paid for. And this is just how it works in the CIP program. So you send in a summary of work effort in the very, very beginning, due in 1 month. So you get right on it, describing what this whole project is about and supply any images and photos you have. And then we do the detailed technical design review 3 months after subcontract execution. So you're preparing for that quite early. We've developed some design evaluation procedures for each topic area, and what the technical monitor will do is extract a basic outline, quite similar to what I presented on yesterday, send it to you so you can start working on that report and PowerPoint over a 3-month period. And then after 6 months, you turn in a report on the issues found in the design evaluation. After 11 months, almost a year after execution, you've done some work and you've generated a report on problem resolution efforts. 13 months later, you put in your final design documents and some plan for or any testing that has been performed on maybe components. 19 months later is the report summarizing the work performed and the results of the final design and testing work detailed in task 4.6. And then the final report wraps it all up 21 months later. So it's about a 2-year process almost, with a final LCOE calculation. for the end of project. Now, to keep us informed, we want you to submit regular quarterly reports. Every 3 months, send in a report on what's been done in that quarter. So maybe one of these deliverables, like a report on implementation of problem resolution. It's like you're really waiting for this blade testing to be finished, and so that effort could be a little late because you're waiting for something to happen before you finish the report and send it in. But these quarterly reports are not late, because even if you just haven't finished a lot of balls in the air during that quarter, we want to know what you have been doing during that quarter, which balls are in the air, what are you waiting on, and so those should be kept on time. In addition to quarterly reports, which really help with communicating project progress, we hold some regular calls, just check-in calls, typically monthly, unless something more substantial happens, and regular email discussion. And what if, so Mr. Kogan says, what if you can do it faster? So yes, you can submit early. We plan per this, we put in due dates, and then, deep in the accounting machine, we put in an accrual schedule so the accountants know when the money's coming out. But if you want to send in something early, that is okay, and we can deal with that. And so I'll write that down. Early deliverables. Thank you, Mr. Kogan. Equals okay. Yeah, that's okay. And now I've put in the scoring criteria for this topic area from the last RFP, and so that when you're developing a proposal, you can really speak to the issues which the reviewers will be scoring against. Okay, so let me just preview. 50% of the score is technical approach, readiness, and a competitive LCOE. Okay, it's like, are you ready, and does this make sense? Are you ready, and does this make sense? So we see ideas that aren't ready, and we see ideas that don't make sense. And if that's the case, they score low. But that's, it's hard to put a filter on there, because you may design something for the Arctic, like a 100 kilowatt machine on a tilt-up lattice tower that doesn't need a crane and serves village microgrids very well. That's not going to be competing with the same LCOE or the same cost of energy as a wind turbine for small farms in the Midwest. Does that make sense? So there's no deterministic filter on the LCOE. It's just you have to make a case on, look, this is going to be competitive at this projected LCOE, and here's why. Maybe it's a different market or application. And so it, it all depends on the details. 25% of the score is on the development plan. So the detail, you seem to understand the challenges ahead. You have a timeline of developing your idea and what you expect to accomplish. And you're not making a wind turbine, period. You're making a wind turbine to sell into a market. So what's your market development plan? Where and how are you going to sell these to? And how are you going to install and support them in the US market? What impact is this new idea, this new turbine, going to have on the US market? And how do you plan to get there? We want to see that you're already thinking about certification and what's the path, what's the planned path to certification? Now that's pretty articulated for you, right? You get a prototype, you finish product development. you put it up for certification testing and you certify it. But we want to see that you have a plan to get there. Like, how am I going to estimate the loads on this? Do I use simplified load model? Are there aeroelastic modeling tools available? Do I have to do some loads measurements? Who's going to do that? Where am I going to test it? So just think through that, because the more unique the design is, the harder those answers are. Because, and that's not a conspiracy. That's just because the pathway that has been built is more, the standards, the testing organizations, certification bodies have a comfort zone, and everything's written for a certain archetypes. And if you're outside of a suite of known archetypes, then your path forward could be challenging, and you need to sort of articulate the understanding of that and a plan. Just going to make sure everything's cool here. Okay. Okay. 25, and we're missing 25%, right? The team. Now, so we've looked at, are you ready? And does this make sense? And do you have a plan? And now, do you have a team capable of pulling this off? And so what's your experience in wind? What's your experience in the market? Who's on your team to provide the expertise needed to execute? We, as we understand in this industry, your company probably is not the magnitude of Vestas or GE or Siemens. It's probably a small company. And so we see a lot of partnering with consultants. We are fortunate in this small industry to have well-qualified, helpful consultants to make up for a lack of expertise on your in-house team. And we and don't just, put a list of names there. We want to see that you've reached out and started discussions with some team members, so that you build a team that can pull this off, and you demonstrate the ability to execute this projects, and maybe you can show that through past work, past experiences, resumes, things like that. The award amount for this topic area is a maximum $200,000 from NREL, or at least it was last time, and with a standard minimum price participation on of 20%, which we got a lot of good details on from Kendall yesterday on what's allowed and what you can use for that price participation, and things you do not want to use NREL money for, because there's some ownership issues to avoid or to consider. Okay, finally, some examples in this space include a 2018 award for Pecos Wind Power. And it's fun to look back at it's not my project, it's a Scott Dana project, but it's fun to look back at their reports and see the just as intended refinement of their initial idea into their final prototype idea. And they've progressed into prototype manufacture and installation, and are working toward putting it up in, on a dyno, up in the air, working on manufacturing. And so it's a pretty, maybe a classic story of a refinement of a 3-blade horizontal axis, 85 kilowatt upwind, active yaw wind turbine. Targeting a large rotor, low LCOE. X-Flow is a vertical axis wind turbine with a very top shelf team. And I guess I have a lot of respect here, because the VOT path is more difficult. The design tools are few. Understanding the flow and understanding the loads and the fatigue issues of VOTS is challenging, and their X-Flow had a 2019 award to develop their 20 kilowatt at the time, 20 kilowatt VOT. I think it's 25 kilowatt now. But they're doing a scaled approach, start small and move up. Windward Engineering had a 2019 prototype design to develop of a large rotor diameter horizontal axis wind turbine with pitchable blades as a retrofit to some previous, endurance designs to increase annual energy production and stay within the acceptable boundary of loads. That's the challenge, right? As specific power goes down, rotors go up. As rotors get bigger, loads go up. So that's where some really innovative engineering comes in. Ducted wind turbines speaks for itself. It's right there in the middle, a 3-blade downwind ducted wind turbine that is moving through their refinement of their prototype design with their 2019 award. Downwind, I think. And Accelerate is an example of a 2021 award with a 5 kilowatt. Now, here's where Ian accidentally invented a word on day one. Horizontal, he accidentally said, which may be what we have here. It's a X-Flow VOT on its side. So we have a 5 kilowatt horizontal wind turbine in a spoiler system, a diffuser. It's augmented flow device to be designed to install on the parapet or edge of a building as shown there in their depiction. So these are examples. Some are conventional, some are unconventional, but we've got horizontal, vertical, and horizontal and augmented flow devices, all being awarded subcontracts in this topic area. Okay, now any questions on this topic area? Let me look at the chat for a minute while you work on it. And it's a pretty small group. I would say unmute and ask all you want. Let me see if we caught up with Alex Kogan. LCOE is affected by wind distribution in the area. Boy, that is a true statement. Now, all the money on top is the same, right? Pretty much. Like the technology costs the same whether you put it in a very windy area or if you put it in a not windy area. So what's changing is the kilowatt hour part on the bottom. And how shall it be reflected in LCOE calculations? All right, so we just, to compare apples to other apples, I would say it makes sense. No, that's a good question. It makes sense to just say, what's the AEP at a site with a hub height, average wind speed of 6 meters per second? And we know that LCOE will be higher in lower wind regimes and possibly lower and higher wind regimes. So that's one possible route. If you're designing for very high wind events, then you've got to realize that those wind events are way out on the Weibull distribution, but that'll come out in your AEP calculations if you're designing for only high winds. If you're designing for low winds, then you'll calculate AEP with the assumed wind distribution. So it's a good question in that I'm under the impression that we want to do AEP at 6 meters per second per the LCOE spreadsheet. But to be honest, I'm going to have to seek some clarity because that field in the spreadsheet is not locked. And so if you calculate AEP at a different wind speed, there needs to be a justification on why. And essentially what we're looking at is this design going to result in a competitive LCOE with a stated market in that stated market? Okay. Yeah, Erica likes horizontal, which Ian accidentally made up. And then Mr. Kogan says, if the turbine itself designed for 8 meters per second average per year, then that's fine. You're going after that market. And so think about the US. If you're designing for markets with at least 4 meters per second average wind speed, then that's maybe a lot of area colored. Now you drag the slider to say, okay, what about areas that have at least 5 meters per second? Now you have a smaller market. 6 meters per second, it shrinks a little more. 7, 8 meters per second, you've reduced your market area. And so you need to articulate how you're going to be successful targeting markets with an 8 meters per second average wind speed. Does that make sense? It's like you got to justify that that's going to be a success. And so that's kind of on you to do that. You may try to do that and say, wow, I didn't realize that the 8 meters per second average wind speed market is so small. Does this make sense? And maybe it does. Maybe that's a unique market that you're going after and you show how to be successful there. For a small company, it's enough. Look at Colorado. Okay, well, again, you have claims that is in the proposal. You support them with some analysis and do your best to put that into the proposal so the reviewers follow, understand, and score accordingly. So again, this is all being recorded. Just a reminder as we get into questions, you don't want to accidentally release any IP that's sensitive because we're going to post this recording, and I'm going to try not to say anything embarrassing or incorrect. We have 15 minutes left because we start the next session on the hour. So we will just basically chat for the rest of the time. Or just take a little break at the end. Okay, Ken, is the evaluation based only on US market viability or on international markets also? Yeah. Yeah, no, that's a great question, Ken. That's a great question.
Well, the only reason I asked that was, obviously there's a US market, but realistically, we have incredibly cheap electricity in the US.
Yeah.
And, you go down to the Caribbean and the price is triple that. Even Hawaii, which of course is part of the US, has a higher markup rate. And then there's other instances. I mean, if we're looking for markets to sell our turbine, where I might be targeting critical infrastructure, where cost isn't even an issue. I mean, that's, or remote communities that are operating on diesel or different kinds of things. So I was just kind of wondering and of course you can't say anything about the upcoming one, but maybe your experience on the past, it's a whole different can of worms for your LCOE if I've got triple the cost for electricity where I'm going to. And I'm still saying, obviously we're a US-based company. Obviously we're hiring people in the US and creating jobs here, but we're looking more towards a global market rather than the US.
Yeah, no, that's a great point, Ken. And I think, I think the overall question is, what's the impact on the US market? So if you're going to test your turbine in the UK, manufacture in Italy, and sell them to the South American telecom industry, then what's the US market impact? Not much. So we're looking at it in that light. On the other hand, if you're a US company and you want to test at a test site in Pampa, Texas, and certify with SWCC and then sell to a global market and have manufacturing and a combination of assembly in Pennsylvania and globally sourced components. That all makes sense. And there is a US impact there. But I don't think there's surely not a requirement somewhere that says you have to just sell to the US market, because we know that's not a reality. We know that export markets keep US companies in business. We want to help increase the competitiveness of distributed wind in the US, maintain this leadership role we have and help maintain a competitive stance. So I think it's fine to say and beneficial to articulate your diverse market that moves outside the US boundaries. But just keep in mind, we are thinking, what is the impact to the US market? Is it just jobs and manufacturing? Is everything export? Then if that's your plan, that's your plan. And that sets the stage of, what the impact to the US is going to be.
Okay, thanks.
Yep. Yeah, I can't say I know how that's going to be scored, but it is part of your plan. Okay, Alex, you've got your hand up. I see it. Let me just hold on. Let me make sure I didn't go off topic. Joe says, I think you could still try to articulate all of that in your proposal. I agree. You'll have to be, okay, you're talking to Kent, to Alex. You will have an LCOE based on 6 meters per second to be compared to others, but also the ability to demonstrate your market. Yeah, that sounds right.
I was talking to Ken. Talking to Ken in the background there as well.
Okay, good.
I agree with what you said.
Okay, good. Okay, Alex, you had your hand up, I think, but I can't hear you. I can't hear you. You're not, let's see, you're not showing muted, but your headset may need to be
okay,
there you go.
now.
Yeah.
Okay, good. All right. I'm very glad that Joe is here. Okay.
Well,
Joe
me too.
Yes, Joe personally was not testing, but at least was participating in testing one of our prototype in upstate New York.
Yes.
And basically, Intertech people, they mentioned that our turbine is the most robust what they ever saw. Okay, I went a couple of times to Caribbean island, especially to Barbados, and I was told, because after a couple of hurricanes last couple of years, a lot of conventional wind turbine was destroyed there. And they have cost of energy over there probably 22 cents per kilowatt hours, maybe even high, up to 30, right? And they are major. Okay, my question is, when I'm providing my application, right? You are giving some reviewers, but let's say in my particular case, one of the biggest advantage is robustness, that our turbine is performing in high extreme wind condition. And what's happening that it's overperforming conventional wind turbine with wind speed above 17 meters per second and underperforming with wind speed below 15 meters per second. That's why when we calculate, let's say, LCOE on class 1 or 2 wind areas, right? We very much overperforming our LCOE very close to utility scale wind turbine. But when we are talking about small wind area, 4.5, 5 meters per second, of course, our LCOE is very high. But our turbine is specially designed for high extreme wind condition. Now, question is, if reviewer, what you're choosing, kind of get used to analyze turbine for the normal wind condition, he might know, he can have limited knowledge or expertise about high wind, load requirements, and basically what is the major component of your turbine is interested by our potential customer, let's say in Caribbean or on the Colorado mountain region. Okay. My question is, do we have, I understand that after you approve project, this is a lot of communication between, let's say, team and NREL and other specialists and so on. But for us, the most important to go over this acceptance procedure. And what we read in our previous reviewer report, they don't understand what we are saying, what is our system is designed for. I would say we are writing there, our system designed for high extreme wind condition. And they're saying back, okay, high extreme wind condition is not enough market.
Right.
Actually, and I have no access to them. I understand that I don't have to basically contact real people. But I would like to be able to contact some intermediary like NREL, okay, and say, you know what, I disagree with this reviewer on this and this and this point. I understand somebody has to make final decision, but actually it's you guys.
Mm-hmm.
Okay.
Yeah, and the issue is that, as Ian articulated, it's a very competitive solicitation, so we have way too many good proposals for the money in our pockets. And so you may have a viable idea and still it's not awarded because we can only award the top few.
No, I understand this and I am not arguing. I'm not saying that we are the best, we have to be awarded. My basically concern is we are not awarded. It's my business that we are not awarded because of wrong reason.
Right.
Understand, if we are not awarded because of right reason, whatever is your criteria are, I no problem.
Yeah.
Okay.
And well, that's why I put all the dirty details of the criteria here and how they're weighted. So a lot of is this a valid technical approach? Are you ready? And does the LCOE make sense for the market you're intending? So, if it's too extremely high wind speed, you're going to be challenged to find a site where that LCOE makes sense.
I can give you a list of this site. And this is exactly point. Maybe you are right. But if I would ask this question, that, okay, I can go, let's say, in my personal experience, after last reading reviewers, we had two choices: to go to try, find, and make market report where our system will work, all right, serious market report and give it to you. But okay, we have a letter from Caribbean Committee, from some Colorado institution, from electric company in Hawaii, saying that we have extreme wind here and we are looking for your system. But at the same time, we decided to modernize, optimize our system for low wind. Right now, we overperform, according to our data, overperforming conventional wind turbine beginning with 9 meters per second. But still, we are low on low speed, but there is no power there on the wind, all right? Yeah. That's why basically, I'm just afraid that we are taking this very seriously, all right? We have very good team. We have fully capable manufacturing facility to produce up to 1,000 systems per year, right? We have all of this. We have 500 people in manufacturing facility who are producing turbines for the 50 years, right? Question is, we have money. That's why basically I don't need your money, right? But what I need basically recognition It's not about money. It's
Right.
about that somebody to understand. If I can get somebody through NREL who will understand or have a discussion of understanding.
Right.
Okay. That
Yeah,
basically
sure.
yes.
Well, yesterday we talked about this a little bit. How do you establish trust? Units in the field helps. You know, people really distributed when success seems to cluster. In other words, this farmer put one up, he likes it. That the neighbors like it, and so on. Units in the field helps. Certification helps. But what are other ideas for de-risking the introduction of new technology? And that's kind of where that's kind of where you live right now, it sounds like.
No, but we had our system. We collected more than 1,000 data in Colorado mountains,
Cool.
right? It was, we have all these 1,000 hours data, and it's, we know how our system produced. And basically for 2021 application, I put link to this report. We have this report on our website. I don't know yet what reviewer would say, but at least we have ability to check. No one was even checking this report.
Did you did you contact Kindle and request some feedback from the proposal reviewers?
2-3 times, and
Okay.
I mentioned this once, but I hope that I will get this soon. It's basically my two questions right now. I would like to see what reviewer said.
Yeah.
Okay. And basically, I would like to show you my system, what we have right now, with data, with everything, and so on. And basically, for you, honestly advise me, Alex, is BS, right? It will not work. Stop it. We are not interested. Nobody will interested. Or basically to give me direction.
Yep.
Right.
Yeah, you may get a more pointed, you may, as we're running out of time, let me just finally say, you may get more pointed, blunt feedback from an independent consultant as compared to, you know, public servants. So keep that in mind. Otherwise, your approach, Kindle can't provide any feedback until all the contracts were signed. They were only recently signed. And so you should be expecting that feedback soon, Mr. Kogan. So just hang in there a little longer. Thank you very much.
Thank you.
Yep, we're out of time, folks. So thank you so much for coming. And hopefully we made this topic area clear enough. And we look forward to some amazing proposals in a future round, hopefully. So
Brent, just this is Luis. I'm sorry. You know, just if you have 1 minute, then you know, is it possible then to just reach out directly to you regarding questions about this design? Because for us in our technology, it seems like we're still behind some of the steps that we need to do before. But we just need to be sure, because we don't want to work, you know, spend a lot of time working and, you know, not even eligible. So it's okay to write an email to you and to Brent directly?
Yep, I'm Brent. Send it to me and Ian. That's the best way to do it right now, Luis.